All right, everyone, we're going to take some toolbox notes on factoring. So the title of this toolbox should be Factoring Quadratic Expressions, and we're going to talk about these special cases. So the first special case we're going to talk about is difference of squares. If we were to write difference of squares symbolically, it would look like this u squared minus w squared. So let's take a look at this example. In this example, we have 4x squared minus 25. Now 4x squared is a perfect square, meaning that something multiplied by itself will equal 4x squared. 25 is a perfect square. And the important thing to remember here is that this is a difference. So this has to be negative. And we'll learn about that why in a minute. So something to keep in mind is that we have 0 x's. So that middle term is actually 0. If you need to write it that way, please go ahead and do that. We put our 4x squared in the top left and our negative 25 in the bottom right. We know if we multiply these numbers diagonally, it's going to be this negative 100x squared, and I'm going to put that in the top of my diamond problem. So I'm looking for two numbers that multiply to negative 100x squared and add to this 0x. Hopefully we know that that's going to be negative 10x and positive 10x. Something to keep in mind is that these numbers are exactly opposites. We've got a positive and a negative 10. When we fill them in our area model over here, we'll end up with one side being 2x plus 5 and another side being 2x minus 5. So when we write our final answer out, again, we have these opposites. That is something we get with difference of squares. We'll have 2x minus 5 and a 2x plus 5. They'll be exactly opposite. The second case we're going to talk about is this perfect square trinomial. So written symbolically, that looks like u squared plus 2uw plus w squared. Let's take a look at another example. So we have x squared minus 10x plus 25. I'm going to first fill in my area model with my x squared and my 25. If I multiply those values, I'm going to get this top of my diamond, which is 25x squared, meaning I want two values that multiply to 25x squared and add to negative 10x. Something cool about this is we can get this as the same thing, negative 5x and negative 5x. And that's how we get this perfect square name from. These are going to be the exact same, which means when we fill them in here, we'll get one side as x minus 5 and one side as x minus 5, meaning our actual answer can be written as x minus 5 squared. Something important to remember about this is because the dimensions are exactly the same, this is a square. It is not just a rectangle. If we were to build this with our algebra tiles, it would form a perfect square. Awesome. So get that page copied down, and then this will be our second page of notes. Here's an example of why that negative in our difference of squares is important. So this is something that is not possible to factor. We're given a 4x squared, 25, and this plus in between is what changes it. So keep in mind we have 0 x's on this as well. So if I fill in my table and I have a 4x squared here, a 25 here, I know if I multiply diagonally, that's how I get this 100x squared. Meaning I need two numbers to multiply to 100x squared and add to 0x. So I hope you guys are seeing the problem. We would need opposites to add to 0x. Like before we had a negative 10 and a positive 10. But a positive times a negative is negative. So we would not get a positive 100x squared that we need. We would be getting a negative. Okay, and that's why this is an example of something that is impossible to factor. We need this to be a minus sign and not a sum. Okay, the last thing we're going to talk about is factoring completely. We talked about this in class. There are a lot of different ways we can factor numbers. So in this example, we've got 3 times 8, 6 times 4, and 12 times 2 are all ways to factor 24. But the only way to factor 24 completely is to have 2 times 2 times 2 times 3. So if we take that into our quadratic expressions, we know that we put our 4x squared here and our negative 6. And I'm just going to show you kind of two different ways that this can happen. So we multiply these across, we're always going to get this negative 24x squared on top. We need to add the negative 10x. And the two numbers that will help us get there are negative 12x and positive 2x. If you don't trust me, you can check it and let me know. So there's a couple different ways that we could factor this And in one way, we'll end up with a 2x plus 1 and a 2x minus 6. That's how I get this one on the left. If we look at it a little bit differently, we can also do a 4x plus 2 and an x minus 3. We'd end up with this expression right here. But something we need to look at right here is that there is a factor of 2 that can be undistributed. It can be pulled out from both of these expressions. So right here in this parentheses, we have 2x minus 6. And a 2 can be undistributed from here, giving us 2 times x minus 3, and then we keep that 2x plus 1. On this side, we see this 4x plus 2. We can undistribute a 2 from there, giving us 2 times 2x plus 1 and this x minus 3. And these are equal. So this line right here is not factored completely. This line is factored completely. In class, we mentioned that if you can tell from this very beginning that all of these terms have a 2, then you can undistribute a 2 in the very beginning. And you end up with a 2 times 2x squared minus 5x minus 3. And you can do your diamond problem and area model with this expression. And you will end up with this answer as well. So both ways work. And that is all for Toolbox Notes today. Have a great day, guys.